Hey guys, so welcome back. Today we've got something rather domestic to work on here. This is a small cooler. It's made by, I don't know who it's made by, but the brand name on it is Vissani. It also comes with a lot of other brand names on it. I'll put a list of them somewhere down here and you can maybe see your brand there. For what it's worth, the model number on this is really long, so I'm just going to put it down here in the bottom so you can see what the model number is. So this thing has quick cooling, and make a quick measurement inside here. Yeah, it's currently 73 degrees on the inside of this. Alright, so I've repaired one of these before, and what the problem was is it's called a PTC start relay, which stands for positive temperature coefficient. It's a type of thermistor that basically gets the starter coil winding to get going, to get the compressor running, and then once it reaches a certain temperature it drops out and then the motor continues. I think that's how it works. The part that we're talking about that I'm suspecting and I'm hoping is the problem will look like this. This is a part that I keep on hand because you run into these things one way or another. If not me, then buddies or something like that. So what I'm going to do is open the back of this thing up and we'll see if that's what we have inside. Okay, so this is the back of the unit. I'll put the label up there where you can see it on the screen better than what you're seeing here. But it just shows the schematic, and on there I'll point out where the PTC relay is on the schematic. And meanwhile, what we're going to do is get down here to the bottom and we're going to get this thing opened up. Okay, so we have the cord unplugged, and what we're going to do is go in and we're going to remove these screws that are down here along the bottom. We'll get this thing open and then we'll see what we have inside. Okay, so it just comes right off. And while we're in there, we'll go in here and clean the coils up in here to make it cool more efficiently. And the item of interest we're going to have is this item right over here. Okay, this is the compressor. It's still warm from when I unplugged it. And the PTC relay and the overload relay are located in this little box right here. So let me get you reset up and then we'll explore into this. Okay, let's see if we can get into this box here. I don't remember the trick. It's a bail that goes on here and it's got a couple of hooks on it. I guess what you do is you push this down because it's got a kind of a spring on this side. Push it in and you'll see it disengages that. And then you just kind of lift that up if I can. Okay, try again. Let's try the smaller one. There, and that lifted that little hook off. And this will allow the cover to come off with maybe a little bit more finagling. So it's just kind of hanging down there. You just have to get something in there and push it down out of the way. And that bail comes off and the cover comes off, as you see. So that's how that was in there. And I just went in there and pulled that up like that to where it would let go. You see? Okay. Alright, so in here you'll see the old PTC right here, and we'll see if we can get that off of there. And let's see what it has on there. It's got a blue wire here on this post, and I believe this black wire on top that goes to the overload. I think we just leave it like it is. Okay, let me see if I can get the blue wire one off. It's on the bottom post here. Well, the PTC is coming off the compressor, so we'll go ahead and pull it off. So what it is, there's a couple of prongs that will be marked M and S on the PTC starter, motor and starter, that have a pin that come out of the compressor, and this is pushed onto those pins. So you can just pull the whole PTC off the side of the compressor, and that's what I'm just going ahead and doing here. Okay, so those are the two pins, M and S. And then over here, I just have this one blue line that comes down here to the terminal on the bottom. I may have to get some needle nose pliers to help me with this. Okay. So the blue lead goes on the lead that's not opposite to each other from here. All right. And here you can see where it says, let's see, M and S for motor and the starter winding. Okay. Let's see, we have a number here that says W, looks like 80593 Foxtrot. You hear the rattle? That's usually a sign of a bad one of these relays. So here is a replacement. You hear no rattling. Okay. Let's put this one in. All we got to do is attach the blue line and then put this onto those two terminals that are coming out of the compressor. So I'll just go ahead and push it on. I guess it was like this, right? Yep. So it just pushes straight on, like that. Then you put this onto here. All right, and it's on. And yeah, I know you guys, are used to people saying, be careful, unplug things and all that. Okay, I know. What I'm going to do is I'm going to plug this thing in and see if the compressor will start it. Let me back you up just a little bit. Okay. We'll plug it in and see if something happens. Plugging in now. I heard the controller beep. This is kicking on. And this is running. I can feel it. Okay. What I'm going to do is let it run for a bit to verify that it's cooling. And then what I'm going to do is I'm going to unplug it again and clean up all of the coil and everything like I was talking about. And I'll put that cap back on. Let me let it operate for a while, make sure it's going to work. This should get really hot. It hasn't gotten hot yet. Okay, it's at 88 Fahrenheit currently. 89.5. So it should warm up. Okay, it's just been running for a few minutes, but I just did another quick check on the inside, and it's dropped from 72 to 64.5. So this thing is working. I'm going to shut it off so I can clean around the fan a little bit better, and then I'll go to put the back on, plug it back in, and then we'll be done. This slot is for that blue lead. Yes, the compressor is warm. It is indeed. Put that in position, and then these bails should just snap into place. And there we are. Back cover on. Also, sometimes if you find you have one of these things that makes a lot of racket when it's running, the fan is hitting this shroud. You can get in there and try to adjust it some. You just end up having to bend this metal here and get to where this is not slapping up against the shroud here. Okay, it's been several minutes. I'm going to plug it back in. It may have a timer before it allows the starter to restart, but that's typical of refrigeration units. And I hear it running. Okay, so what I'm going to do is I'll show you the part number that I bought and what I paid for this. So yeah, the part that we had in there, this is the one that was in there. Here, rattling. Here's the actual part number on it. You might be able to see it now. I was looking at the number here earlier, but the actual number is located here. And you should be able to see it there. It says QP2-4.7 G12. Okay, and these things are not expensive. You can buy these online on Amazon for about $5, $5 to $6. The trick is that for about $1 more you can get 2 of them. So what I normally do is buy them in a pack of 2, and that way I've got an extra on hand for myself or any of my buddies or anybody in the family that has one of these things go out. You know, you've got one of these little cheap parts that you're easily replaced. There's that part number, QP2-4.7. Okay, and I'll show you where I maybe got this online. But it's just Amazon, okay? And I don't do affiliate links or anything. Just search it yourself and look for a good deal. And like I say, don't be ashamed to get 2 of these. You know, they're kind of handy to have around. Notice I didn't get into looking at the compressor, checking the resistance of the windings, doing anything to do with the controller board. The overload switch. You can buy a replacement overload switch at the same time you get these if you want to, but so often this is the problem. And so rather than going and do a bunch of that other troubleshooting, I just said, okay, let's get this thing out. Does the old one rattle? Yeah. Does the new one rattle by comparison? No, it doesn't. Okay, so that's kind of a tell. All right. So then, if you have these on hand, stick it in. Thing starts running, great. If the compressor's bad, what difference does it make? You're not going to repair it. I mean, once you have to get in the Freon system on this, you just get a new one. Okay, it's not worth the money. But for a $5 fix, save yourself a bunch. So anyway, hope that helps you guys. Things are humming right along, and I'll be able to get my drinks cool again. Okay, guys. So welcome back to the bench. This is think of this as like an epilogue. So I was editing this together. I filmed this back in October. We're now in February. One of the things I thought would be, started off was I found this as I was cleaning up some stuff, and it reminded me that, hey, let's do a follow-up, because that cooler is still working just fine. So if you're wondering, is this really all it was? I'll put a video here. I just filmed this a few minutes ago, and as you can see, it's working just fine. And it's been working fine ever since I did it. Okay, so I thought we'd do 2 things. Let's open this up and see what's inside. We hear the rattling. What's rattling? And then, I'm calling this a PTC, which is positive temperature coefficient. There is a word missing there, which is thermistor. So this is a positive temperature coefficient thermistor. Now, if you've watched any of my other videos, you know that I use thermistors in some of my repairs of old radios where I want to see a voltage drop, but I want a soft start going into these things that have a big power draw at the beginning. And for that, I use something what you've heard me call a CL90, which is a thermistor. I thought it'd be interesting to compare these two because they do the opposite of each other. So these guys here are CL90s. These are NTC, negative temperature coefficient thermistors. So let's compare the two. But first, why don't we open this thing up and see what's inside and what the heck's rattling. I took a look at this. So here's a bit of a close-up of what I was looking at a little while ago. You'll see there's 2 sockets here that the pin from the compressor goes into. One of them is M for motor, and the other is S for starter. Motor winding, starter winding. Now these pins just go through and connect to these points back here, but you notice I had that outside wire hooked up here. So I believe what it does is this wire goes to both of these, but they have different resistances across here that allow the starter to get a different voltage at the beginning. And the starter happens to be on this side. You see the S right there. Okay, let's get this thing open. How do I open it? think I'm getting close. Maybe it opens this way. There we go. Okay. I've opened one of these before when I had done a couple of these before. Okay. There. So what do we got? So here you can see the way the contacts come in, and they've got that piece of material, that disc, sandwiched in between the springs on this side and on this side. So that's the part that's broken, and that's what made this thing no longer work. So when you hear these things rattling, it's because that element in there, which is this type of semiconductor, has failed. So you can see this contact here goes straight across here to this blade. So there doesn't seem to be any resistance change between that post and the one that's marked motor, if I remember right. Right, motor. But then to get from this one to this one, it goes through the semiconductor, right? And this is for the starter pin. So this changes its resistance with voltage and current going through it, with temperature, because what it does is it heats up. Okay, so why don't we see if we can make up a demonstration of how this works using another one of these that I have that's new, it hasn't been used, doesn't rattle or anything. I'm not going to open it up, I don't want to damage it. We know what it looks like inside. And so what I thought I'd do is see if I can figure out a way to maybe demonstrate how this works. It's designed for line current as the CL90s are. So I thought it'd be interesting to compare their behavior to each other if I can. So let's see. One of the other things I thought we could do is let me get you where you can see this meter a little bit. Alright, let's measure the resistance. So we know that, we mentioned a second ago, that we can see that this and this are connected together. Right there. Yeah, see, no resistance. Now this will have infinite resistance because the piece is missing, but let's get a new one here. So we get a new one. Okay. So from this location here, motor, to this pin location here should vanish. It does. But from this one to this one, we're going through the semiconductor, and it starts about 5.1. I believe this thing here, this one doesn't actually have the markings on it. This one does. It says QP2-4.7. I believe the 4.7 is supposed to be its cold resistance. I'm not sure. Maybe we'll find out. But 4.7, maybe that's what they mean by 5. I don't know. But we will see. All right, let me see if I can rig up a way where I can put 100 volts or 120 volts from here to the starter winding. And rather than trying to measure the resistance across there, which of course you really don't do, what I'll do is I'll measure the voltage drop across here, and then that'll show us the behavior that we're looking for. So we get that rigged up, I'll bring you right back. Okay, I'm showing a little bit of my test equipment that I have over here. I use a variac to vary my input voltage that I use in testing of different types of equipment. If you don't have this kind of equipment, don't attempt any of this sort of stuff. In fact, don't attempt this at all, period, anyway. Let me do the work and you show it and you can look at it. This is an isolation transformer that makes it to where if I touch one of these leads, I'm not completing a path to ground through my feet. This is a dim bulb we have back here. There's a light bulb that Don't quite see. I'll tip you up just a moment. There's a light bulb back there. This is a I think I've got a 150 watt bulb right here. I can vary that depending on how much power requirement I have for the various tests I'm doing. Okay, now what I've got is I've got this rigged up to where I'm going to be measuring voltage across the CL90. But what I want to do is show you what the dim bulb does. So the dim bulb is in series with the power line here. And what that does is that limits the current going through here. And I use it a lot in test equipment. If you've got a dead short, it will keep it from burning things up. A lot more information than that online. I'm not trying to teach you how to do this. If you do what I'm doing here, you're at your own risk, folks. So what we're doing here is I'm just show you, if I were to short this, you'll see a big spark, but that light will come on back there in the back. Well, I've got to turn it on first. And so we get a spark, and that bulb lights up back there in the back top right, if you see there. Okay, so that's limiting the current going through here. If this has been a short, so that's limiting it to, I think it's about 1.5 amps or so. It's 1.8 amps. It's 150 watts. Otherwise, I could be getting 15 amps through that. Okay, so let me turn this off again. And what I'm going to do is have this go through the CL90. Like I say, you've seen me use this on my channel several times. And what I want to do is measure the voltage across the CL90. So the CL90 is a negative temperature coefficient item. I use this to limit inrush. So as this thing turns on, it gets hot, and the resistance goes from high to, as the temperature goes higher, the resistance goes lower. So it's a negative temperature coefficient. So what it'll do is it'll resist an inrush, therefore it'll have a high voltage drop across it, and then as it heats up, the voltage across it will slowly drop. Okay, so we're going to do that now. We've got it turned on and be putting 120 volts across this through the dim bulb. And we just want to watch the performance on the meter. We're on the 150 volt scale, which is the top scale. So as you can see, it went up high to 90 and it's dropping away. So it showed that it limited that inrush by providing a 90 volt difference across here. So it ate up 90 volts of this inrush voltage that was coming in, but then as it got hot, it rapidly dropped down to where it's almost not limiting the voltage at all. Just a little bit, and I do use it for that purpose. A little bit of a voltage drop at the end. Okay, so that was a negative temperature coefficient thermistor. Now let's look at the PTC, the positive temperature coefficient thermistor. So what this purpose of this is that the that's hot. That's why I'm trying to touch it. The compressor in the cooler has a higher resistance to get started, so it needs a little extra boost. So what it does is it has the starter winding in there helping it, but then as it gets warmed up and gets going, then the starter winding drops away and it runs on just the motor winding. And so what you'll see is that this will allow the starter winding to get current and run, but then as this warms up, then we'll see that the resistance of this starts to go up and cause the motor winding to drop out. Okay, and so what we should see is we'll see a voltage come up here, and then we'll see the voltage increase because the resistance will begin to increase rather. So I had to switch scales. I'm going to be on the 15 volt scale. So once again, as this warms up, its temperature will increase, and since it's a positive temperature coefficient, its resistance will increase. So the voltage across it will start off relatively low and then go up as it heats up. And this one doesn't work as fast as the CL90. It has a different temperature time. Okay, we're going to cut it on now and see what happens. Well, I guess I need to hook up my voltmeter. Okay. I switched to the 15 volt scale. Let's see what happens. Okay, it jumped up quick. That's probably more a reaction of the dim bulb operation. So we're on the 15 volt scale, so we're at 5 volts across the PTC. Now as this thing warms up, let's watch what happens to it. 5.5, 6 volts, 7 volts, 8 volts, 9 volts, 10, 11, 12, I'm turning it off. So what you can see is as this thing gets hotter, its resistance across it started to really quickly climb, and of course the voltage across it changed as a reaction of that. So there's a difference between a CL90, which is an NTC, and this starter thermistor, which is called a PTC thermistor, or we call it PTC. But that's what it stands for, and that's what it does. Hope you found that interesting, guys. Talk to you later. Thanks.